Hello, everyone. So this is a review of the proof of concept that we implemented for the side editor re-architecture. This proof of concept is a proof of concept of the WYSIWYG editor using the CKEditor5 framework. That is both a WYSIWYG editor that outputs HTML and a framework that we can use to build custom editors. So in this session, we are going through the, well, let me share my screen first. So what I'm saying has some context. On this session, we're going to review the contents of this merge request and the product of the code of the implementation of the code that we have here. Basically, we defined an evaluation criteria that this proof of concept is based on. What we wanted to evaluate with the proof of concept was determining what is the payload size of an editor that is built with CKEditor. If it is possible to create to have multiple instances of the editor in the same context, evaluating how the editor behaves in mobile devices in small screens. And then two advanced use cases are very specific to the static site editor. That is implementing a visualizer for template syntax within Markdown documents. For example, one common example in the handbook is embedding ERB code snippets within Markdown document. And the other one is switching between the WYSIWYG and raw Markdown modes and retaining the cursor selection. Something that that is a bug that we haven't been able to fix with our current solution. So before jumping right into the code, let me show you I implemented this proof of concept in GitLab UI. The advantage of implementing it in GitLab UI is that we have access to the history book. This is a very convenient environment to implement a proof of concept because each of the evaluation criteria have their own story. We can test it in isolation without changing or impacting the code that we have already in the static site editor. It is a very good environment to test libraries in isolation in general. So first, I opened the review app. You can open this merge request and then go to the review app that will open a version of the storybook that contains the stories that I implemented, which is very convenient if you don't want to check out this branch locally. And I created these 5 stories that match each of the evaluation criteria that I talked about earlier. And within those stories, I used what CKEditor calls a classic editor, and I included all of the features that we have currently in the static site editor, like basic formatting of text, inserting links, images, lists, and a table editor. And the block quotes are also some basic formatting. Besides that, the editor includes a block toolbar that basically tries to simulate the user experience of Notion and Medium, where each of when you are starting a new paragraph, you can choose which, in this new block, what kind of content you are trying to introduce. In the case that I want a list, then I start immediately with a list. So let me give a little bit of context about how CKEditor provides this kind of functionality. CKEditor provides two types of usages. The first one is the pre-built versions of the editor. They create 5 versions of the editor that provide different type of user experience. The first one is a classic editor. That is the one that we were seeing in the history book, where you have the common experience of a text box here, a text area, and then you have a toolbar with all the features that the editor provides. But then you have other types of build, like the inline editor, where basically you can have these text boxes that has a floating toolbar on top. And the balloon-nator, that is the one that we were talking about, where you can have a toolbar for each of the blocks within the content. The other type of development experience is using a framework. And this is the one that we are interested about. And it's like basically each of these pieces of functionality that the pre-built version of the editor provides, you can use them as individual components to build your own editor. So let's go to the, well, I'm gonna go through all of the stories that I implemented here before jumping into the code. First, we have this default view. I implemented a story with multiple instances. The idea was testing if we could actually do this. It's a very simple one. And it's pretty much multiple instances of the same editor, and there is not much else to say. But the idea is demonstrating that it is possible, and it is actually possible. The third one is a one of testing the editor in a mobile viewport. I'm using here a feature of the history book that allows to create a context, a story where you can see a smaller form factor. And the feature that CKEditor provides is like creating a responsive toolbar that will hide items depending on the size of the screen. In this case, the classic editor toolbar is hidden, and the items that, I mean, it is hiding part of the toolbar items because they don't fit in the screen. And the same is true for the block toolbar. So they will make it responsive as well. Another feature that I noticed is that when you're using tables, building a table, this is also like it adapts to the size of the screen, which is very convenient. I think this is one of the most attractive features of the CKEditor.
Yeah, I just saw the merge cells. My eyes just went, whoa. That's really cool.
Yeah, and this is as an observation about merging cells. I think that these are features that we need to limit within the editor, because I think Markdown doesn't provide that. So it's probably something that I think that we can actually do it, but usually the flexibility that the editor provides to in tables is can be a liability for us, because if we cannot do things like, we can do things in the editor like inserting a list within a table, but this is not a feature that Common Mark provides. So we need to find some way of limiting that.
Thanks for that. Thanks for that caveat.
The fourth story is about displaying code snippets inserted in Markdown. I'm gonna talk a bit more about how we implemented that, but basically we can implement extensions in the editor that allows to to identify these code snippets that are not part of the common market spec and then display them in a specific way. In this case, I just made a very simple visualizer that is displaying these code snippets as code blocks. But at some point, I guess that we will want to perhaps interact with them and open, if they are referencing a template, we could open that template dynamically and things like that. And all of that is possible with the editor architecture.
Can you make that block not editable?
Yes. Pretty much, you can you identify these code blocks, and then you create some categories, or you extended the document schema. The document schema is basically like saying, hey, we have a document, and that document can have a paragraph and can have lists, but perhaps lists cannot have a block quote inside them. And the schema is a data structure that creates those constraints within the document. So you could say, hey, we will have this kind of code blocks within the editor in the schema, and say, well, these code blocks won't be editable. And that's one of the, of the features that provide the document schema, creating that kind of constraints. You can also say that it is not draggable. You can say that it is not nested within a specific element. It is very, very flexible. And the last story is the cursor position. So basically, if you go here and set your cursor in, I don't know, some random place, and you switch to the raw mode, your cursor will stay in the same position. There are some caveats to this feature, because the way that CKEditor models the selection is very different from what the DOM uses, because well, I'm gonna speak in more detail about that, but now that this is the demo, and what matters is that at this level it's very possible to do, and CKEditor provides the tools to do that. So I'm gonna jump back to the merge request. I'm gonna talk about the first topic, that is payload size. So how do we build this story? How do we include CKEditor in the history book? So when you're using the CKEditor framework, I'm gonna open the package JSON file. As you see, you have many packages that represent each individual feature in the CKEditor. You start with the CKEditor core that is a package that contains all of the functionality for the document schema and the document model. Probably it's worth opening this page here. Basically, the editor architecture has 3 layers. The model that represents like the data that is inside the document. A view that represents like the actual visual, the visual representation of the model, and the controller that converts the model to the view. So all of these functionalities comes as independent packages. In the case of we have the core that represents the model, and then all of the other features like paragraphs, tables, links, like the most basic constructs of the editor comes as independent npm packages. They are basically plugins that is the same design construct that we are going to use that we could use to implement our extensions. And besides that, they also provide other packages that are very useful that serve for development purposes. For example, one of my favorite features is this development dev inspector that they provide to inspect all of the data within the document. Let me see, do we have more instances? Oh, this is counting all of the instances that I've created in the editor. So look at these development tools. We can use that to see how the data within the document is structured. In this case, we have like a paragraph, and then like the CKEditor is modeling this styling here. That is like an embedded ERB within a link as just normal text that is that has an attribute that is called data embedded code, and that is a plugin that I actually implemented to detect when we are just displaying embedded code within a Markdown document. So this was very useful, and it's like a really good tool to debug what we are doing while implementing features. It has also a view mode and commands that are a way of just applying actions in the editor. So jumping back into the code, I added all of these packages to the package.json as dependencies, and then I had to add a custom Markdown parser that I used to implement the extension to recognize the ERB syntax within the Markdown document. I'm gonna talk a bit more about Remark, but basically we're using a separate Markdown parser instead of using the package that CKEditor5 provides, because that one is not extensible. I generate some stats about the CKEditor package, and the editor is actually very heavy. Counting all of the packages, I'm gonna actually generate it again, so we can see a dynamic version of the report. But pretty much this is one of what in my opinion is one of the biggest disadvantages, something that probably we want to discuss with the CKEditor team tomorrow. But the editor is quite heavy. Even the core of the engine, the core of the editor, that is the most basic part, is like it requires a lot of bandwidth to download because it has a big size. And besides that, these stats here, let me see if this is finished, almost finished.
While that finishes, the interesting thing for me there is, even though it's relatively much larger than Toast UI editor, the gzip size seemed to be less than Toast UI.
That's right. I don't fully understand the part, but I imagine it's because Toast UI is already optimizing and including some libraries optimized within the package that cannot be optimized further. So we could say that we could build a lighter version of the editor if we remove plugins like the table one that is like 266 kilobytes, and the image one that those are essential features that we probably cannot just not include because they are essential part of the editor. And probably if we want to use this WYSIWYG editor in a different context, like using it for the comment section, we cannot exclude them either because we can also use tables in those contexts. So that's the most difficult challenge of using the editor. And these stats are including the CSS and the SVGs, but it's not including the parser that I'm using. So I'm gonna look for it so you can see the size of that module.
Sorry, Enrique. Dumb question on my part. In the scenario of using multiple instances of the CK editor, is that like 3 times the file weight size on the page, or is it just like it gets loaded once and it just creates a new, like, does every instance result in like whatever the gzip size is, like 500 kbs of
No, it's just we only load the assets once, and then each instance of the editor is just it just takes the space in memory of that instance, of that object in memory. So it's not like duplicating these one are like more like the physical assets that are downloaded, and after that each instance represents just like some runtime. It just takes a space from the runtime memory.
gotcha. Thank you.
That made me think now that apart from the initial payload, it would be good to see, how much memory an instance takes up. Especially if we think about wanting to enable an editor on Commons, and somebody's viewing an issue on their mobile phone with like hundreds of instances, that might be quite bad experience if it's not done intelligently to not be in all of those instances in memory.
That's right. What I'm imagining is a merge request with 50 conversations or 50 nodes, and by error we decide to create an instance for each of them. I think that the best way of structuring that is trying to have a single instance of the editor as much as possible. But I think that is another something else that we should measure as well. That's right. So the Markdown parser is way smaller, but it's still like it has a significant. I could say that it's also somehow significant, even though it's the size is way smaller. But this one in particular is it has 58 kilobytes, and I think that soon they are creating a new version that is called MicroMark, that is gonna reduce the size further and improve the performance. So that's bundle size. Besides that, I think that from the point of view of the code, what is more interesting, because the mobile view, the multiple instances, and all of this structure around the classic editor is something that is out of the box. I didn't implement anything important or anything significant other than assembling all of the parts and including them. I'm gonna show you quickly that. So pretty much I created a view component where I'm including all of the packages that represent the basic formatting options and the objects that we can embed here. And then after including all of those packages, I created an instance of the classic editor, and I included all of the plugins. So that's the easier part, the easy part. The complex part of the proof of concept is implementing recognizing the ERB templates and displaying them in the editor. So I'm gonna focus on that from now on. And after that, I'm gonna speak a little bit more about the maintaining the cursor selection between editor and raw modes. So I'm gonna start in parsing the markdown. We have, let me go to the story. We have this test content. It has some markdown paragraphs, and then it has some custom ERB syntax. The first that we have to implement to recognize those ERB snippets is a tokenizer. So we start with a markdown parser that is called remark, and then remark, what the markdown parser does is taking this raw markdown, this raw data, and converting that into a structured information in the form of an abstract syntax tree. And an abstract syntax tree is pretty much saying, hey, we have the root of the tree, that is the whole markdown document, and then this paragraph will become a node and a separate entry, and the type will be a paragraph, and this one will become another paragraph, and that node will have some children, and those children will be an HTML, an inline HTML, and besides that, it will have an inline ERB code snippet. So that's the whole purpose of the Markdown parser. And after we create that structured version of the Markdown document, we have to teach remark and how to convert those nodes to HTML. So that was the main focus of the Markdown part. Let me show you how that works. Here. So we have the Markdown converter, and we are creating basically an instance and extending. Is it? Well, no, I have to start by the to HTML because I was talking about the Markdown to HTML conversion. So first we extended the parser with the ERB parser. And what is the ERB parser? It's basically a tokenizer is like a function that is accepting the raw Markdown document, and then is iterating through all of the character and implementing a function that we recognize within that raw string where a ERB code block starts and where it ends. So we would have to implement this kind of parser of tokenizer function to detect all the custom template syntax that we want to provide some custom visualizations within the editor. I don't want to go through the actual implementation, but basically that is like you create that function, you specify to the parser, hey, you're gonna have a block ERB and an inline ERB tokenizers, and you have to specify some priority. In this case, I said, hey, I want you, the only tokenizer that is more important than you is text. So if that text tokenizer is not recognizing something that it can consume, then all of the content will be scanned by the ERB tokenizer. In that way, we can extract the ERB code snippets before other tokenizers can recognize other types of syntax. Like we want to recognize the code snippets that are inside the HTML. In that way, we can like treat those parts of the document as special objects. So after we have the actual abstract syntax tree with the information that we want. We create a map here in the Markdown to HTML converter, and we say, hey, we are, well, before that, we are tagging the ERB code snippet as embedded code blocks. That's the type of node that that's the way that we name those nodes. And then in the Markdown to HTML converter, we are saying, hey, if you find an embedded code block node, I want you to generate this kind of HTML. And the HTML is basically a pre tag that will have an attribute that is called that embedded code. And inside that pre tag, it will have a code one that is marked with ERB. And that will be the HTML that the editor will consume. And until that, that's great, but then we need even another step to convert that HTML to something that the CKEditor can interpret. So I'm gonna go to the ERB, to the editor part. Perhaps something that would be useful is to see that in the inspector. I'm gonna start the storyboard. So the editor has plugins, and all of these are plugins. And then we have to also implement a plugin that teaches the CKEditor how to convert the HTML that we generated to data that they to a node, well, to a part of the document model. So we implemented our own plugin that is a embedded code plugin. And let me show you the implementation. Something that I always find a little confusing is that if I click here, I don't know if I'm going up or down. Sometimes I'm going down. So this is the embedded code. You know that I was talking before about the schema, document schema, where you specify what can be in the document and how it can be organized and what is allowed hierarchy. So this plugin is extending the schema to say, hey, you will have text that will have an attribute called data embedded code, and that will help us to identify the ERB code snippets. And there is a plugin, the code block plugin, that is what we are using here. But that, well, let me show you. I always open the wrong thing. So CKEditor provides the code block plugin that represents a specific structure within the document schema, and it allows a single attribute, the language one, and it's used to display this little tag here. But we wanted to reuse this plugin, and we needed an extra attribute to detect if we are just displaying a code block that is actually an embedded template syntax within the document. So we extended the code block schema to support that new attribute, that new flag. And here's the way that we are sending that. After that, we need to indicate CKEditor how it will convert that raw HTML to these models here. And that's a concept that CKEditor called upcasting. And upcasting is basically saying, hey, you will find a code HTML tag, and it will have a data embedded code attribute. I want you to convert that into this model, the data embedded code. And in the case of the upcast for the code block, that is the big one here, it will find a pre tag with a data embedded code that will be the view, the HTML, and it will convert that into the code block model with a data embedded code attribute. And this is called upcast because it is the conversion from the view to the model. But you also have to teach CKEditor how to do the opposite conversion from the model to the view. And this is what this code is doing. Saying, hey, you will have this model, and this is a way of creating an HTML tag to make the conversion to the HTML that we will convert back to Markdown. So what is the general outtake of this? We will, like, this is a representation of this architecture. Like this is a concrete implementation, sorry, of that of this diagram here. We are using a rich container with a custom document model that we have to convert back to HTML, and we are using the unified platform to create a bridge between the editor and the Markdown parser that is converting back and forth between HTML and Markdown. So do you have any comments or observations, questions?
It looks pretty good in the amount of customizability you were able to do with that, and by creating your custom ERB parsers and stuff like that. Totally off tangent on this, but I noticed that in the CK editor, there's actually like lots of node position information. So like the paragraph, you can almost like pinpoint the position of everything. Did you play around with that in any capacity, or?
Yes, I did. That was one of the most challenging parts of implementing the proof of concept. And the cursor position. Look, I'm gonna select one part of the text, and you can go to the selection part in the developer tools, and you can see all of the information about that selection. You can see where it starts, where it ends. You can see even what are the attributes and what is the formatting of the text that you selected. So it's incredibly powerful. And the data structure, the way that CKEditor structures the selection is as a tree, because let me see here in the path. Let's say that I come here. The path property here says it is a tuple of well, it has the first dimension is 0, and that represents the first block here, the first paragraph, and the second part, the second dimension represents the position where you are within that block. So you could be 064, and it is the same case for the second block. It's like, well, first dimension, second dimension, third dimension, but there is a space between those paragraphs, and CKEditor is not counting that. It's not counting that as a dimension. If you go to the raw version, you have actually 1, 2, 3, 4 lines. So you have to find a way of mapping that tree and that structure to something that is completely different. And that's the challenging part of handling the conversion between the cursor in the text area and the rich container. But it gets even more complicated. If you go to a code block, you get a third dimension. So you are in the third block in the first character. But if you jump to the second line, you have this property index that is saying, hey, you have 3 elements, 3 levels of you are in the third level of the tree. You are in the I think this is the third block. It is counting the characters with the offset, but then within this code block you have more elements like soft breaks. I think that we can see it here, and you have text nodes. So it is like selection is treated as a tree structure, and when converting to the raw version, we have to I create a small algorithm here that is really very ad
Well,
hoc.
yeah, I think for a proof of concept, this is pretty good. Where I was going with this is like going back to the one thing, like jumping to position. So for example, if we're kind of going from the handbook and we use that pop-up tool that Chad implemented months ago, you can jump right to the line. And it feels like with all this information, you can get closer to than just manually guessing like what we were discussing in the past. It feels like there's more information and mapping information to jump.
Yeah, I think that we could even if we know
That might be hard because you're not in the editor already, so you don't have any positioning, just the raw HTML. I guess you'd have to parse the HTML and somehow see how that maps to the editor blocks.
Okay, cool. Yeah, don't let this my comment and distract the core aspect of this demonstration, which is like the power of the CK editor. Yeah.
No,
I think the
no,
core
thank
aspect of this demonstration is how much Enrique did. This is incredible.
Well, no, actually, that's a great question, Michael, and perhaps something that we could do is that, well, I don't know. It's like we are jumping from HTML to Markdown to a model in the CKEditor. So yeah, it's quite complicated. But I guess we could find a solution at some point. But yeah, this is the core part of the. Hopefully, this demonstrates the capabilities of CKEditor, and how we can combine all of the elements to achieve our goal of displaying these complex Markdown documents.
Great job. Buen trabajo.
Gracias. Thank you, Chad. So if there is, do you have any observations or questions?
It looks awesome. The license and the payload are the two things that worry me, and they're pretty significant worries.
Enrique, we talked a little bit about yesterday about your developer experience. Can you maybe just for the record share a little bit about that as well?
Yes. So I'm gonna share my screen again because I think that my comments can benefit from that. The framework, the CKEditor framework has an extensive documentation of the architecture and some examples about how to do these conversions. But those examples and that information, even though it's very useful to understand how the editor is created, in some cases it's not specific enough. It was not specific enough for me to understand how I could achieve the things that I achieved in the proof of concept. For example, they have this code snippet here about how you can use an advanced version of the converter that has a dispatcher that triggers events every time that a node will be converted. But there is nothing here that helps me to know what I should do with the dispatcher. So I had to go to the API documentation and say, hey, let me see if there is some examples here in the conversion document, and try to find code examples in the API, and that was not always immediately easy. Like it wouldn't be helpful. So the API is extremely complex. There is 3 ways of converting a document model to the view, and it's difficult to choose between them. So I think that even though there is extensive documentation, the complexity of the API sometimes is great. Is like undermines the benefit of having such documentation. This tool was very useful to understand the basic concepts. Sometimes like inspecting and being able to see the underlying data in the editor instead of like inspecting the HTML was incredibly useful. So that was very beneficial. But in general, that was my experience. Like you have this documentation, but you have all of these packages. You don't know exactly what all of these categories means, but actually all of these categories represent independent NPM packages. And I had to figure out figure all of that out on my own. It was not something that was very that was evident by just looking at the documentation and looking at the picture, well, and all of this. There were other times, for example, I felt that this pictures section here represented something that was oriented to a stakeholder, to someone who is making business decisions, so they could see what the editor was capable of. This is also in API the framework documentation. You can see how you can, what package you can install, and then how you can include those features. And that was very confusing. And in general, even though the architecture is very well documented, I had to read this like 100 times to actually understand what's going on. I think this is something that that will represent also a meaningful aspect to make a decision, because in the case of TipTap, even though it is not as well documented, the architecture is way simpler, and Prosmeter is a structure all of these pieces in a simpler way than the CKEditor. Cool. So if there aren't more questions, I think that we are done here. Thanks everyone for joining, and see you on other occasion.
Thanks, Enrique.